All right, cool. All right, so chapter 5 is about repetition structures or loops, right? So in chapter 4, we focused on selection structures. And so there'll be some similarities here. Just like with selection structures, you've got like a logical expression or a condition that evaluates to true or false. And, if it's true, you do, with selection structures, if it's true, you do one thing. If it's false, you do something else. With a loop, usually if it's true, then you'll go back and repeat stuff, okay? So here's what we'll do in this chapter. We'll learn about repetition structures or control structures or looping structures. The main loops we'll focus on, the first one we'll look at is a while loop. So the while loop is kind of like the most versatile type of loop, So that's what we'll spend most of our time here at the beginning looking at. But then later on, we'll look at for loops. And then finally, at the end of the chapter, I think they talk about do-while loops a little bit. We'll look at some different ways or different scenarios of using loops. And so these most common ones include counter-controlled loops, sentinel-controlled loops, flag-controlled loops, and end-of-file loops. So these are like different scenarios about how you would go about using a loop. Okay. And then later on, we'll look at the break and continue statements and how they work with loops. We've seen the break statement before with switch statements, right? But you can use those with loops as well. So we'll see how that works. And also, we'll look at like nested loops. That's a loop inside of a loop. So you can use that to your advantage. And so you can put, multiple loops inside of loops. So you could have a loop inside of a loop inside of a loop if you wanted to, depending on what you're trying to do, And then, so nested loops get a little bit more complicated and confusing. But usually we just have a loop inside of a loop or something. And loops, we'll use loops for all kinds of things for the rest of the semester. So your program 2 has one loop in it. But later on, when we start doing one-dimensional arrays, you have to use loops to do anything with arrays. And with two-dimensional arrays, use a nested loop structure. So this is important stuff that we're doing. All right, so those are the main things. So just real quick, think about loops, for example, and repeating something. So far, we've just look at the circle program, just real quickly, and that was like the first program we did, right? And so it would calculate some like the area, circumference, and things of a circle. Well, that was one circle, right? But what if you wanted to repeat that and do the same type of thing for multiple circles? Well, you could kind of duplicate all those statements and have all those things in there multiple times, right? But that would be kind of overkill and kind of silly to do that. Or you can just use a looping structure that will just repeat those same steps over and over again. So they can kind of automate things and make things easier to write. All right, so here's a while loop. So here's how you write a while loop. You put the word while, and then inside of parentheses, you have an expression. And this expression is a logical expression, just like we had with if statements. It evaluates to true or false. If the expression evaluates to true, you go inside the loop, and you do whatever is inside the loop. If the statement evaluates to false, you exit out of the loop, and so you go to the next thing after the loop. Just like with if statements, if you only have one thing that goes inside the loop, you just have to put that statement. But if you have multiple statements that go inside the loop, you have to group those inside of curly brackets. With the loops, you're usually going to have multiple statements inside the loop, especially while loops. So you're probably going to have curly brackets, underneath there. All right. And they mentioned a couple things like the expression acts as the decision maker. It's usually a logical expression. The statement is called the body of the loop. Again, that's usually you're going to have curly brackets like a compound statements and stuff. Right? And you have to have the parentheses, the outer parentheses, just like we had to have with if statements. So if you're into flowcharts, this is what it would look like visually. So you're going along, and then all of a sudden you get to this logical expression that evaluates it true or false. If it's true, you go back and you repeat stuff, and you keep repeating until that's false. And so you finally, when it's false, you exit out. Okay. And so if it's never false, you have what's called an infinite loop, right? A loop that goes on forever. And so, and with all these things, you're going to have certain things. There's three main parts of a loop. And I would usually write this on the board, but since I'm recording this, we'll see how this goes. You're going to have the first thing. Oh, wait, I had to do the pin, right? The first thing you're going to have, does that work? Pin. There we go. First thing you're going to do is initialize. I'll just put init. So you're going to initialize your loop control variable. Right? So a lot of times you'll have a variable called, but not always. This is going to look different depending on what type of loop it is. A loop control variable is just that. It's a variable that controls how the loop works. Okay? So with all these loops, the first thing that you're going to have to do some kind of initialization before the loop test. Okay? So that's the first thing. You have to initialize a certain condition. And then the second thing is you test your condition. Okay? And then the third thing you have to do, usually at the end of the loop, you're going to update. You're going to have some kind of update. I totally screwed that up. Update. There you go. So you initialize, you test, and then you update. Okay? So when we look at the different loop examples, I'll try to point those three things out because it looks, like I said, it looks different depending on what type of loop it is. Okay? And so let's look at an example here. Here's just a simple while loop. Right? So I, in this one, is our loop control variable. I basically controls if I do the loop or not, right? So I is just an integer. In line 1 there, you see I is equal to 0. That's the initialization, right? So we initialize I to some starting point. We started off at 0 in this case. And then the test is there in line 2. I is less than or equal to 20. So as long as that's true, it's going to repeat, okay? And then inside of the loop, inside of the curly brackets, all this one is doing is just outputting I in a space. And then in line, what is that, line 5, you see I is equal to I plus 5. That's your update, right? So we're adding 5 to it each time. And then after the loop is over, it'll exit out and it'll just go down the next line. So what does that do? So you just plug in the numbers, right? So I starts off at 0. 0 is less than or equal to 20. That's true. So it goes inside the loop and outputs I, which is 0, in a space. So you see down at the bottom what the result is there. So it outputs 0 in a space, then updates I to 5, adds 5 to it, and then tests it again, right? 5 is less than or equal to 20. That's true. So it goes inside the loop, outputs 5 in a space. I becomes 10, so it adds 5 to it. 10 is less than or equal to 20. Yes, so outputs 10, adds 5, so it's 15. 15, so you see what's going on here, right? 15 is less than or equal to 20. Outputs 15, adds 5 to it. 20. So I is 20. 20 is less than or equal to 20. That's true. It's equal to 20. So we go through this one more time. Output 20. And then I becomes 25. 25 is less than or equal to 20 is false. So it exits out. And so the output is 0, 5, 10, 15, 20, right? So the loop goes through 5 times. But so everybody see how that works? And again, there, I is your loop control variable. So we have to have all those parts, right? So like over here, what happens here? So they modified that example just a little bit. Instead of I being, the test being I is less than or equal to 20, they just have it I is less than 20. And they start off I at 20, right? Instead of 0. So what would that output? Nothing, right? So you just plug it in. So it's going along, it sets I to 20, and then a test is 20 less than 20. Well, that's false, right? Right at the very beginning. So it doesn't do the loop at all. So it just exits out of the loop, and actually goes down to the next line. I guess technically the output would be a blank line, you know? So there, your initialization wasn't set up right, probably. Or what happens if you, like back on the original example, what happened if they didn't do this? What if they didn't do the that part, the update? What if you didn't have an update? Yeah, it would just output zeros and go on forever, right? Until you finally, like, either close the window or did a control break or something like that, or control C, some command or something to stop the program from running. So you have to have all the three parts. You have to have the initialization, your test, and your update. Good. All right. All right. So different types of scenarios, and like I said, next week we'll actually code some examples, and I think it makes more sense. I think they might have some examples in the book. So if you're kind of following along in the book, you might be able to see some actual examples. Yeah. So there's some examples after each type of thing, I think. So, but we'll do some examples next time. Counter-controlled loops. So you use a counter-controlled loop when you know exactly how many times you want the loop to go through. Usually that's the scenario. So your loop control variable is some kind of variable, maybe usually like an integer or something like that, that's going to keep count of how many times you've gone through the loop. And so it will update. So your loop will, a lot of times if you're going up by one every time, if you're counting up by one, your loop will be something like this, so you'll start your counter off at 0 or 1 usually, and then you'll test while counter is less than however many times you want the loop to repeat. So that's what they're called in. And then at the end of the loop, you'll have your update, and so if you're going up by 1 every time, it'll just be like counter plus plus, or that means counter is equal to counter plus 1. So it just goes up by 1 every time. But technically, a counter control loop could also go up by 2, or like the one that we saw, by 5 each time. It's still the same type of thing. It's counting. Every time I run this, it's going to go through the same number of times, right? So that's a counter-controlled loop. Your loop control variable keeps count. Okay. And then, so that's one scenario, I guess you could say. A sentinel-controlled loop is what we call, an event-based loop. It's based on a certain event happening. You don't know ahead of time how many times the loop is going to go through, right? And so usually, the way a sentinel-controlled loop works, your loop control variable is some variable that you're going to input. The user is going to input, or you're getting it from a file or something like that, although that would probably be more of an end-of-file loop. So, in your update, your initialization, your test, and your update look a little different here, right? So with a sentinel control loop, your initialization is you're going to get the first value. So sometimes we call that the priming read. So you want to get the first value, and then you test to see if that input value that they just input, as long as it's not equal to this special sentinel value, you're going to repeat the loop. So the sentinel value is some kind of special value that is going to signal that we want to exit out of the loop. And so what you usually want to do is you want to choose a sentinel value that's not a possible valid value for the input variable. Okay, this one will make more sense when you see an example. So a lot of times it might be like while your variable or whatever it is not equal to like negative 999. If you've ever seen that before, like that's what people used to use in the old days, like a negative 999 or negative 9 or some kind of negative number, assuming that the normal values are positive numbers. It might be something like that. And then your update at the end would be just like your initialization, but you're going to get the next value. Okay? And usually you want to have some kind of output statement that goes along with that so that your user knows what the sentinel value is and how to get out of the loop. Okay? So again, we'll look at an example and it'll make more sense. But that's a sentinel controlled loop. I'm going to go on. How about a flag controlled loop? So a flag controlled loop is similar to a sentinel controlled loop, but with a flag controlled loop, usually you have some kind of Boolean variable involved. So like their example is maybe you're going to keep reading in numbers or something or do something like that until a certain value is found. So you have a Boolean variable that you initialize to true or false or whatever. So here they initialize their Boolean variable is found to false, and then their test is while not is found. So is found is a Boolean, so that's a true or a false, right? So not false is true. So as long as it's false, it's going to keep going. And then you would have some kind of condition that you're watching out for. So you're usually going to have some kind of if statement in there, and so you check for that. If a certain expression evaluates it true, a certain condition is met, then you're going to trip that flag and change it. So you're going to change it like is found to true. And then that next time you go through the loop, that'll exit out of the loop. So it's similar to a sentinel control loop, but it's just set up a little bit differently. You've got like more of a Boolean variable involved. So it's a flag controlled loop. I like to have a little example in the book maybe of a guessing game. All right. And then the last kind of scenario that we're talking about here are end-of-file loops. And that's what you end up having to use in your program 2 assignment is end-of-file loop, right? So end-of-file loop is where you're reading values from an input file, but you don't know how many values are in there, right? You just want to keep repeating until you get to the end-of-file marker, which is a special character at the end of the file. Right? So just keep going until you get to that. That's the setup for an end-of-file loop. So here's their little quick example. They're just using CN, but it would make more sense to actually have an input file. And so like in your program 2, I've already got that set up for you. So the initialization, you're going to get your first value. So if it was an input file and you named it in file, you'd say like in file and then whatever you're reading in. And then your test is, while in file or while, that input stream. And then your update at the end is just like your initialization. You're just getting the next value. So as long as you haven't reached the end of file marker, it's going to keep going. So, and again, we'll look at an example. Instead of doing like while in file, you could do something like this. There's a special function called EOF, end of file, that checks for the end of file marker. So if you had your input file named in file, you could say while not in file.eof, and it would do the same thing. Although I just like saying while in file. It's shorter and easier. All right. So like I said, we'll look at some examples of those things. Just like with if statements, you can have while loops and conditions inside your loops that are more complicated and more complex. So you could use those logical operators like and or to combine things. So like here, while number of guesses is less than 5 and is not guessed, then repeat stuff. So it can be more complicated. I think they have so I think I'm going to kind of skip over this. They have an example here in the book that deals with Fibonacci numbers. So are you familiar with Fibonacci numbers? Oh, Fibonacci numbers are cool. So the Fibonacci number sequence, basically what it is, it's a sequence of numbers where the next value in the next number in the list is just the sum of the previous two numbers. So if you look at them, they get it started here. Just take any Fibonacci number there, like 3, and the numbers before it, 1 plus 2 is 3, so that's how you get it. 13 plus 21 is 34. The next number, what would it be? 21 plus 34, whatever that is, that 55. So that would be the next number, and so you could keep going with it like that. So you could write you a little loop program or something that would generate, 100 Fibonacci numbers or whatever it is. So that was their example in the book. All right, like I said, I'm going to skip over that. All right, for loops. We'll focus on while loops at first, because like I said, they're the most versatile and stuff. But later on, we'll hit for loops. For loops are kind of cool because they take those 3 parts of the loop, the initialization, the test, and the update, and it sticks all 3 of those parts on one line. So you can look at a for loop and see kind of the setup of the loop, how the loop is structured and controlled. You can just look at that one line at the beginning and see how it works. So for loops are really great for counter-controlled loops. Although you can use for loops to write other types of loops too, but counter-controlled loops are great as for loops. And when we do arrays later on, we'll use for loops a lot. All right. All right. I think I'm going to go ahead and stop there. And later on, when we get to that point, we'll come back and maybe finish the rest of this PowerPoint. Okay. But that's kind of an intro to loops.
Pretty much exactly the same as it was in JavaScript.
Yeah. So, yeah, in fact, JavaScript has a lot of similarities on syntax as loops, as a C++. How do I get out of this? You want to keep your things? No.